We're going to do some more examples of permutations and combinations. So the first one is a pizza shop has available toppings of mushrooms, olives, peppers, onions, and pepperoni. So how many different ways can you make a pizza that has 3 toppings? Now, again, the first question we ask is this a permutation or a combination? Does order matter? And in this case, order doesn't matter, right? If they put the mushrooms on before the olives, it doesn't matter if they, then it's no different than if they put the olives on and then the mushrooms, right? So this is a combination because if I pick mushrooms, olives, peppers, or peppers, olives, mushrooms, it's still the same pizza. So this is a combination. So we remember that our combinations formula is n factorial over r factorial times n minus r factorial. Let's figure out what n and r are. So n is how many things we have to choose from, and r is how many of those that we choose. So how many things do we have to choose from? 1, 2, 3, 4, 5. So n is 5. And how many of them are we going to put on our pizza? Well, we're going to pick 3 of them. So we could write this as 5 choose 3. This is the notation for combinations. But we can just go ahead and plug this into our formula. So we have 5 factorial on top, and then r factorial, which is 3 factorial, and then 5 minus 3. And what is 5 minus 3? Well, that's 2. So we have 5 factorial over 3 factorial 2 times 2 factorial. And you might be kind of tempted to multiply this 3 and the 2 together. Don't do that. Remember, because 3 factorial means 3 times 2 times 1, and 2 factorial means 2 times 1. Because remember, functions don't distribute, and this factorial is a function. It tells us what to do, and so it tells us, take this 3 and do something with it, just like a squared, right? Functions don't distribute, okay? So we can't just do that factorial to everything. So 3 times 2 times 1, and then 2 times 1 is basically what we're doing. So we could just put this into our calculator. We could, if we wanted to, we could write this out as 5 times 4 times 3 times 2 times 1 over 3 times 2 times 1 times 2 times 1. And then we could cancel out things that were the same, right? The 3, the 2, and the 1. And so then really this is just 5 times 4 over 2. So you could actually do this in your head without even doing this in your calculator. This is 20 divided by 2, which is 10. So we have 10 options, but let's do it in our calculator because oftentimes you can't do it in your or in your head. So we're going to do 5 factorial divided by, and remember to put your parentheses, 3 factorial times 2 factorial, enter, and we get 10. So there are 10 different pizzas that you could choose from that number of toppings. So maybe you're a pizza shop owner and you want to advertise how many awesome different choices you have. Well, there you go. Math, real life. You could do math in real life. Yes. Okay. A lot code has a code of 3 numbers between 1 and 10, and you can't repeat the numbers. So I know this is hard for you to imagine because in most of our digital locks, you can totally repeat numbers. But we had a lock on our house for a while. It was just like a little key, safe, so that if we lost our keys, then we had a key in there, right? And it was manual, which means like once you pushed a button, that button couldn't be pushed again. Because it was just like this manual thing where you actually took a screwdriver to turn on that number and say, okay, that number is one of the ones that would push. I know that's hard to imagine that that's possible, but those kinds of locks do exist where you can't repeat a number. So this is a lock code. We can't repeat numbers. And we want to figure out how many different codes we can get. So is this a permutation or is it a combination? Does order matter or does order not matter? In this case, order absolutely matters, right? 1, 2, 3 is different than 3, 2, 1 on most locks. So order matters makes it a permutation. So what's our permutation formula? N factorial over n minus r factorial. Okay. And so what is n? How many things are we picking from? Well, there's 10 different digits we could choose for each of the lock numbers, right? For each time we pick a number, it could be one of 10 different options. And then what is R? How many of them were we actually picking? We're actually picking 3. So we're going to do 10 factorial over 10 minus 3 factorial. So this is 10 factorial over 7 factorial. So we could put this into our calculator, or we could remember that that would basically be 10 times 9 times 8, right? Because the 7 factorial would cancel out everything after that. One thing I want to remind you is sometimes this is written as P with parentheses 10 comma 3, or as 10 permutations of 3. So those are some very, very common notations that just get used to seeing those so that if you see them, you know what they're asking. So we could put this in our calculator, or we could figure this out on our own. We could figure out that this equals 72. And so 72 times 10 is 720. Or let's look at how to do it in the calculator. So we do 10 factorial divided by, we could even type in 10 minus 3 factorial. As long as we put it in parentheses, we're totally fine, right? And we get 720.